Okay, Assalamualaikum and hello. Okay, welcome back. So we continue. Okay, before we continue, make sure you check in your attendance. Okay, at the e-learning. Okay, I will place it there. Okay, and I just want to remind you that your assignment due date is almost over. So make sure you complete the assignment one, which is in group, and make sure you submit it before the due date, which is, if not mistaken, next week. Okay, also make sure you clear your calendar at 10 January 2022. You have test 2. Okay, the information about test 2 is available in e-learning. Make sure you check the date, the time is 9 p.m. Make sure you clear your schedule because the test will be conducted at that time. Okay, so today we continue with the next part of the generation, chapter 3. Okay, so we already discussed about thermal power station. Make sure you practice to do this. Now we continue with hydroelectric station. Okay, so this one, okay, if you recall back, this one is type 1 using electrical generator, and then this one without involving heat. This one is just only potential energy. Okay, not potential, mechanical energy, direct conversion. Okay, so hydroelectric involve conversion of hydraulic energy into electrical energy. Okay, hydraulic energy into electrical energy. So the main component you need to know, okay, of course the reservoir. Okay, the reservoir, the dam. Okay, this one is the dam, this one is the pressure channel, this is a surge tank. Okay, this is the valve house. Okay, penstock, and then this is the powerhouse. Okay, so I think you can see the mouse, right? Okay, so basically the surge tank is when you close down the valve, the pressure will suddenly increase. This is why we put a surge tank. Okay, so this is the function of surge tank, and then the penstock is basically the height, okay, of the water. Okay, and then the powerhouse where you place the generator, okay, the synchronized generator. So make sure you know how to draw this, how to label it properly. Okay, so this one I think I already explained it to you. A dam is constructed across the river or lake to form a reservoir. So you can see here, this is the dam, this is reservoir. Okay, a tunnel is built to connect the dam to a large pipeline called a penstock through a valve house. So this one, okay, valve house to the powerhouse, you have a penstock. Okay, this is just a valve. A surge tank at the top of the penthouse is to protect the penthouse against the sudden increase in pressure occur if the turbine opening is suddenly closed due to rapid decrease in electrical load. Okay, so if the load changes, okay, remember if your load is reduced, okay, the pressure will be, okay, the pressure of the turbine opening will be reduced. Okay, as a result, you need to have a surge tank. Okay, the water will come back up at a surge tank. Okay, in this situation, water pressure is transferred from the penstock to the surge tank, which will increase the water level in the tank. Okay, so energy from the water in the reservoir depend on the volume and different height between the water source and the output. Okay, so the hydraulic energy is basically came from the water and depending on the volume and height between the source and the output. So this is the source and this is the output. Okay, so the height difference is called head. Okay, the height difference is called head. You need to know what is head. Okay, it's basically the height difference between the water source and the output. This one is basically which store the energy is directly proportional to the water head. Okay, the higher the head, the larger the energy store. Okay, to obtain a high head, water from the dam used to move hydraulic turbine is channeled through the penstock to the turbine. So see, this is the head. Okay, head is the height difference. Okay, it goes to the penstock and then goes to the generator in the powerhouse. Okay, so the turbine convert the hydraulic energy from the water into a mechanical energy, which then transfer into generator shaft for sequence conversion of electrical energy. So there is no heat involved. Okay, it's just from okay. Let me. Okay, sorry, it's not responding. Okay, so you have a hydraulic energy. Okay, you convert this into a mechanical. Okay, mechanical energy, and then you use the synchronous generator, okay, to convert it into electrical energy. So make sure you know the process. Okay, so this is a hydroelectric station generator, synchronous generator. So you can see here, this is the cross sectional. Okay, you can see these are the water flow. Okay, so this is the water flow. It will move the turbine blade, okay, and rotate the rotor of the generator. Okay, so make sure you know the generator has stator and rotor. Stator means that it is static, rotor it is rotating. Okay, this is the turbine shaft. Okay, so you have two types actually. The water turbine normally used in hydroelectric station, you have two types. The first one is the impulse turbine. Okay, this is the theory. Make sure you know what is the theory. Okay, impulse turbine is usually we have a high water head. Okay, it is very suitable for high water head. Okay, medium and low you do not use the impulse turbine. So basically you need to have a very high head or high height difference between the source and the output. Okay, so basically impulse turbine, you just have a pipe here and then you have a small opening. It is a nozzle, and then the nozzle will shoot out the water at high speed, okay, at the Pelton wheel. Okay, so as a result you have a you can rotate the synchronized generator. Okay, high water pressure from the nozzle is spread at the turbine blade, and then velocity of water jet drive the wheel. Okay, this is used Pelton wheel. Okay, this is impulse turbine, but sometimes you don't have a very high head. Okay, so impulse turbine is not suitable. Okay, so to overcome this, we use a reaction turbine. Okay, reaction turbine is used for low or medium water head. Okay, for this turbine, water pressure combined with the head velocity used to move the turbine blade. Okay, so the popular example of the reaction turbine is Francis and Kepler turbine. Okay, so maybe I should draw this, easy for you to distinguish. Okay, so you have a hydroelectric station. Okay, the first one you have impulse turbine. Sorry, hydroelectric turbine. Okay, impulse turbine, and then you have a reaction turbine, which is this one. Okay, reaction turbine. Okay, there are many examples, but I only show you two. This one can either Francis turbine or Kaplan KAPLAN turbine. Okay, so you have two types of reaction turbine. Okay, so Francis turbine is suitable for low and medium head. Okay, so this one the different only, okay, this French's and Kaplan turbine is that, okay, the flow is parallel to the axis of the turbine, okay, but the Kepler is flow through the axis of the turbine shaft. Okay, this is the difference. Okay, for French's it is for low and medium heat. Okay, this one is only for low heat. Okay, it's not suitable for medium or high. Okay, so this is Kepler turbine. So French's turbine, maybe I show you the figure. I think after this there is a figure. Okay, yes. So you can see here French's turbine, the water inlet, okay, is at the side. Okay, it's parallel. So this is your blade. Okay, so your water inlet is something here, okay, and here, okay. It's basically rotating, produce the water, okay, something like this. Okay, it will rotate the blade at the side. Okay, that is the French's turbine. Okay, parallel to the axis of the turbine. Okay, but for Kepler turbine, okay, you have water. Okay, this is the blade. Okay, this is the blade, and the water rush here. Okay, so the water rotate here at the top to bottom. Okay, something like this. Okay, so if you want to write this, the water flow through the axis of the turbine shaft. Okay, so this is turbine shaft, so through the turbine shaft. Okay, so this one parallel to turbine shaft. Okay, that is the difference between French's turbine and Kaplan turbine. Okay, now we move on to calculation. Okay, okay, so for thermal, you need to know the constant of 860 kcal is equals to 1 kilowatt hour. But for hydroelectric station, you need to know the constant is 1 meter cube of water is equals to 1000 kg. Okay, so 1 meter cube of water is 1 kilogram, and then another one is the gravitational acceleration, which is 9.81 meter per second squared. Okay, so this constant you need to know. Okay, usually it's not given, so you have to know the constant. So the important formula here is the water weight equals to volume multiplied by the density multiplied by the gravitational constant. So the first formula is, okay, weight is equals to volume, okay, multiplied by the density multiplied by the gravity. Okay, weight is equals to VdG. So weight is in Newton. Okay, this one of course is in SI unit, meter squared. Okay, density also in SI unit, kg per meter cube, and gravitational constant meter per second squared. Okay, every time you do this, make sure you use a constant. Okay, make sure you use the standard SI unit. Okay, so the energy store is basically, okay, E store is equals to weight multiplied by the heat. Okay, this is how you calculate the energy production of the hydroelectric station. Only these two formula. Okay, make sure you memorize this. Water is just equals to volume multiplied by density multiplied by the gravity, and then the energy store is just the weight and then multiplied by the heat. Okay, the unit is watt second. Okay, Make sure also you know the unit. Head is in meter, this one is in Newton. Okay, so we move on to the example. Okay. Okay, we move on to the next. We move on to example. Okay. So okay, hydroelectric station. A hydroelectric station has a reservoir with a water volume. So volume is equals to 5 multiplied by 10 power of 6 meter cube. So you can see here the unit is in SI, so no need to worry. So and the head of the water, the head is 200 meter, also in SI unit. Okay, the efficiency is 75% or 0.75. Okay, so how to solve this? Calculate the energy, electrical energy. So you have to calculate the hydroelectric energy. Okay, remember this one. Okay, where is it? Hydroelectric. Okay, the hydraulic energy. Okay, so you can see here, this is the efficiency is 0.75. This one electrical. Okay, this one is hydraulic energy. So you have to calculate this first, and then you use the efficiency to get the electrical energy. So let me, okay, where is it? Okay, this one. So first you have to calculate the weight. Okay, so easier, just I use E hash hydro. This one is EE. Okay, so weight of the water is equals to V. Okay, V density and gravity. So volume is given 5 multiplied by 10 power of 6. Okay, density, remember the water density here. Okay, so water density is, for water is 1000 kg per meter cube. Okay, so this is important, you need to know the density of the water. So of course 1000, and then multiply by the gravity. Okay, gravitational acceleration 9.81 meter per second cube. Okay, and then you get the 4.91 multiplied by 10 power of 10 Newton. Okay, so the energy, okay, total energy stored in the water E hash is equals to weight multiplied by heat. So 4.91 multiplied by 10 power of 10, okay, multiplied by the water heat is 200 meter. Okay, 200 meter. So you get 9.82 multiplied by 10 power of 12 watt per second. Not watt per second, watt second. Okay, so of course you use this, remember output over input. So input is the hydraulic energy, so E is just equals to efficiency multiplied by, okay, multiply by what is it? Where is it? E hash. So equals to, okay, efficiency is 0.75 multiplied by the 9.282 multiplied by 10 power of 12. Okay, you get the, okay, so if the question asks you to find in the kilowatt hour, of course you need to multiply this. So of course this one, the unit is watt second. Okay, watt second. Okay, so how to convert watt second into kilowatt hour? Okay, so what is 1 kilowatt divided by 1000 watt. Okay, and then multiply by, this is second. Okay, so second, okay, 3600 seconds equals to 1 hour. Okay, so this one is just 60 multiplied by 60. Okay, 60 second multiplied by 60 minutes, you get 1 hour. So if you have to do the conversion, usually the question will ask you to get the answer in what unit. Okay, but usually in electrical you use a kilowatt hour. Okay, so for electrical, this one you will get 2.05 multiplied by 10 power of 6 kilowatt hour. Okay, this is just unit conversion. Okay, the bottom one is just unit conversion. Okay, I think hydroelectric is much more easy. Okay, we move on to the next example. Okay, so we continue with the second example. Okay, where is it? Okay, so you can see here water from the hydroelectric station is 100-meter head. So okay, so the head is 100 meter. Of course, you need to look at the unit, make sure it is in SI. So calculate the electrical energy generated by a 1 cubic meter flow of water every hour. So you can see here 1 cubic meter of water, so volume is 1 m cube, okay, of water every hour. So 1 meter of water, this one for every hour. Okay, so our calculation is basically every second. Okay, so you have to change this 1 meter cubic of water for every hour. So this one volume is equals to 1 meter cubic per hour multiplied by 1 hour divided by 3600 second. So okay, so just use 1 over 3600 meter cube. Okay, so this is the volume for every second. Okay, make sure you calculate this for every second, because if you look at the formula here, it is based on second. Okay, but if you don't want to use second, it also can. Okay, you can use hour, but make sure in your calculation you use the unit hour instead of second. Okay, so let me continue this. Okay, so better to avoid your confusion, we can use second. Okay, okay, now you have the efficiency. You can see here you have two efficiency, of course, two efficiency. So the efficiency of the hydraulic and the efficiency of the electrical. So this one is 0.86 and 0.92. So this is energy mechanical, this is energy electrical, this is the energy of hydraulic. Okay, so you need to find the overall efficiency, because the question asks you to find the calculate the electrical generate. Okay, this one, so you don't want to look at the center. So efficiency of overall, this one is efficiency of overall is basically efficiency of hash and efficiency of E. So 0.86 multiplied by 0.92, so 0.79. Okay, let me check the recording first. Okay, so now you have to calculate the overall efficiency, of course. And now you have to calculate the weight. The weight of the water is, okay, so volume multiplied by d, density multiplied by the gravity, okay, gravitational acceleration. So the volume is 1 divided by 3600, okay. Okay, this is in second, okay, the volume in 1 second, okay, and then multiply by the density of water, 1 kilogram per meter cube, and it's 9.81, okay, gravitational. Okay, so weight is equals to, so let me calculate this, 1000 multiplied by 9.81 and then divide by 3600, okay, so you get 2.725 Newton, okay, and then you have to calculate the hydraulic energy, W multiplied by the head, okay, 2725, and multiplied by the head is, okay, by the head is 100 meter, okay, this is the head, okay, 100 meter you get, okay, you get 272.5, okay, watt second, okay, so this is in watt second, okay. So the question asks you to calculate the electrical energy generated by 1 cubic of meter of water every hour, okay. So remember that I said for E, oh yeah, you have to calculate the electrical energy generated, right? So calculate electrical energy. So electrical energy is efficiency of overall multiplied by E hash. So efficiency overall is 0.79, this one, okay, multiply by 272.5, okay, you get multiply by 100, right? Okay, so you get electrical energy 215.275 watt second, okay. For water you use watt second, okay, but for electrical energy we use kilowatt hour. So E is equals to 15.275 watt second. You have to convert this into kilowatt hour, so multiply by kilowatt, 1 kilowatt divided by 1000 watt, and then multiply by, okay, second is 3600 divided by, okay, second 1 hour, okay. So let me pause this. Okay, sorry about that. This one, okay, this one, so you have to be careful, this is energy, okay. So this one you convert it first to kilowatt, so you divide by this one, so 0.21527 kilowatt per, okay, kilowatt second, okay. So because this is energy, okay, this is the energy, E equals to this one. So this is basically the energy used for 1 second, okay. But for 1 hour you have to multiply by 1 hour, so 0.215, okay, 275, okay, multiply by, okay, this is kilowatt second, okay, So because you want to use this energy for 1 hour, you multiply by 3600, okay, second. Okay, so basically 0.215275 multiplied by 3600, so you get 774.99 kilowatt second or kilowatt hour. Okay, because you use it in 1 hour. Okay, so be careful with this. So you have this one is just a conversion, but this one is the energy used for 1 hour. So you have to multiply by how many energy you use. Okay, okay, make sure you be careful with this. Okay, so that's it for example 2. Okay, this is example 3. I will show you. Okay, so for this question, it's required you to use your little bit of logic. Okay, so let me show you. Okay, a hydroelectric station has a cache area of 24 kilometer square cubics. Okay, so this one is the area is equals to, this is the reservoir area. Okay, so 2.4 km cube. Okay, this one in not in SI unit, so be careful. This is in kilometer square. And the capacity of water, okay, volume is 5 multiplied by 10 power of 6 cube, okay, cubic meter. So this one is in SI unit, so no need to worry. Water head is 100 meter. Overall efficiency of the station is, okay, efficiency of overall is 72.6%. Okay, so the question one is the total energy that can be generated by the station. So for question one, calculate the energy that can be generated by the station. Wait, let me check the recording. Okay, so this one is standard. Of course, you have to calculate the weight. Okay, so weight is equals to volume. Okay, so this one, the total volume. Okay, so this is just to calculate the total energy. Okay, not per second. This is for the total energy. So volume multiplied by, okay, density multiplied by the gravity is equals to 5 multiplied by 10 power 6 thousand. Okay, and the gravity is 9.81. Okay, you get where is it? Oh, I have to calculate manually. So 500,000 okay, multiply by 1000 multiply by 9.81. okay, so you get 49.05 and power of 6, or not 6, 9, okay, Newton. And so the energy of the hydraulic oil equals to quick height. Okay, but for electrical, E is equals to efficiency of overall E height equals to she overall WH, so equals to 0.726 multiplied by the 49.05. okay, so multiply by 10 power of 9, and then the height is 100 meter. Okay, so the EE, and of course this in watt second. Okay, So because this is watt second, you have to convert to kilowatt hour. So 1000 multiplied by 3600, okay, you get 989175 kilowatt hour. Okay, so make sure you know how to convert this. Divide by 1000, divide by 3600, just to convert watt second to kilowatt hour. That's it. Okay, for electrical energy, for the EE, okay, we use kilowatt hour. Okay, for hydraulic energy, we use watt second. So make sure you know the conversion. Okay, so this is how to solve this question number 1. Now we move on to question number 2. Okay, we continue. Okay, so for question number 2, the drop in the dam level if the electrical load of 15 megawatt has to be supplied for 3 hours. So basically, you have a dam here. For example, this is the dam. Okay, this is the pressure pipeline. Okay, you have around this area is 2.4 km squared. Okay, this is the height. Okay, how many does this drop? Okay, after 15 megawatt energy is used. This is E. Okay, megawatt for 3 hours. So this one is megawatt is power. This is power, not E. Okay, power E. Okay, P electrical power. So this is for 3 hours. So you have to convert this into energy. E. Okay, how to solve this? Okay, you can see here. Okay, you can see here. Okay, you want to know what is the water drop. So this is, we put it as P. Okay, just any unknown you want to use. Okay, so this is the volume of water. Okay, so volume of water every second is basically 2.4 km squared multiplied by the P. Okay, P in meter. Okay, this is the volume of water per second. Okay, sorry, this is the total area. Okay, sorry, the total volume of water for 3 hours of use. So you have to, of course, you have to convert it per second. So how to convert this per second? You just divide by 3600 because this is in 3 hours. So 3 hours is 3 multiplied by 3600. Okay, so this is the total of volume of water use. Okay, you have to convert to water release per second. So you have to calculate this. Okay, this is the volume. You want to calculate the volume. Okay, and volume is in meter cube. Okay, and it is in a second. Okay, make sure it is in a second. So after this, you get V is equals to 222.2 P in meter cube. Okay, just to be careful, I'm not sure whether you know how to do the conversion here. Okay, so maybe I should show you one by one to avoid any confusion. So V is equals to 2.4 km squared multiplied by P divided by 3 multiplied by 3600. So this is in km, so you have to convert this in meter squared. So how to do this? You just multiply by 1 kilometer is 1 meter. 1 km divided by 1000 meter. And because this is square, don't forget to square. Okay, so you can cut this. Okay, so where is the calculator? Okay, 2.4 divided by 3 divided by 3600, and you have to multiply by 1000, and you have to multiply again by 1000. Okay, you can see here this is 1000 squared, so you get 222.22, and don't forget the p. Okay, 222.22 p. Okay, p is unknown. Okay, so because the question asks how many water drop. Okay, so make sure you know how to do this. Okay, next, the weight of water released per second. Okay, so of course you just use the formula given. Okay, where is it? Okay, remember W is equals to volume, density, and gravity. So 222.22 p, okay, multiplied by 1000 kilometer per kg per meter cube. Okay, this is the density of water. Okay, make sure you know the constant, and 9.81. Okay, so you have the weight of water is 21.8 p multiplied by 10 negative 5 Newton. Okay, this is Newton. Okay, the generated power is 21. Okay, so the generated power is, if you recall back, E hydro is equals to weight multiplied by the heat. Okay, multiplied by the heat. Okay, and the E electrical is equals to efficiency overall weight heat. Okay, or EH equals to U naught WH. Okay, please recall back the formula. Okay, so you get, let me, okay, the efficiency is 0 point something, 0.726. The weight of the water is this one, 21.8 p multiplied by 10 5. Okay, and the height is 100 meter. Okay, and remember you have to convert this into kilowatt, so you just divide by 1000. Okay, you get 15.84 p multiplied by 10 power of 4 kilowatt. Okay, originally it is in watt. Okay, remember this is in watt second, so you want to convert this into kilowatt second, you have to divide by 1000. Okay, so this is the energy generated at the EE. So EE, this is the EE, and mentioned before, okay, the energy, okay, the electrical load of 15 megawatt has to be supplied for 3 hours. So you can see here, so kilowatt second is equals to 5.84 p multiplied by 10 power of 4 kilowatt. Okay, this one in second. Okay, so next, or you just ignore this. Okay, second. Okay, kilowatt second. Okay, so, and then EE also equals to 15 megawatt. Because this is energy, you can either use second or hour, but for this case you just use second. Okay, either way is the same for this one, for this case. So from this you can calculate P is equals to Okay, 15 because this is mega, this is kilo, so 000 kilowatt seconds divided by 15.84 multiplied by 10 power 4 kilowatt second. So you get 9.47 cm. Okay, so this is the level drop for the water. So this is just a small decrease because the area of the area is very large. The area of reservoir is very large. So that is how you calculate the water drop. Okay, so that's it. You can try to practice to do this question. Okay, try it on your own. Okay, try it on your own first. Okay, that's it. Okay, maybe I will show you how to do this. Okay, so practice on your own first. Okay, so after that, if you want to check whether you have the correct answer or not, you can check the answer here. Okay, so try yourself first. Okay, this is just to show you how to do it after you try it to yourself. Okay, let me check the recording first. So for the first question is direct to the point. So you can see here volume is 15 million multiplied by 10 power of 6 meter cube. So this is in this is already in SI unit. So the head is 100 meter. The efficiency of hydraulic and electrical is this one is hydraulic is 85%. Efficiency of electrical is 90%. So of course efficiency of overall is equals to efficiency of hydraulic multiplied by efficiency of electrical, 0.85 multiplied by 0.90 equals to so 0.765. Okay, so total energy available at the station. So for this case you no need to include the second, I think. Okay, no need to worry, just calculate this. So E is equals to E hash is equals to, or maybe I just simplify this, easier for you to calculate after. So EE is equals to E hash efficiency overall equals to E hash is equals to W hash efficiency overall. Weight is the volume, density, gravity, hash. Okay, so just include everything. So 50 multiplied by 10 power of 6, density is 1000, gravity is 9.81, height is 100 meter. Okay, and then efficiency is 0.765. Okay, you just multiply everything. Okay, let me use the calculator first. So you get 3.75 multiplied by 10 power of 13 watt per second. Okay, this is the unit. Watt second. So after this you have to convert it to kilowatt hour. So 3600 multiplied by 1000 watt second is equals to 1 kilowatt hour. Okay, So this one I just simplified it. So after this you can go a little bit faster with the simplification, but in the beginning you can do it one by one. So I use the calculator. Oh sorry, this is also wrong again, because this is energy calculation. So this one you have to convert, okay, convert to kilowatt hour first, okay, then multiply by 1 kilowatt divided by 1 watt hour, 1000 watt hour. Sorry, I think the original one is correct. Okay, so multiply by 1 kilowatt hour divided by 3600 multiplied by 1000 watt second. So use the calculator. So you get 10.42 multiplied by 10 power 6 kilowatt hour. Okay, so this is the answer, how to solve the question number 1. Okay, for question number 2 is almost the same as this one. Okay, I think you can just try it on your own. Okay, next is gas turbine power station. Okay, I will discuss it in the next video. Okay, that's it. Okay, thank you.